Hello, everyone. Welcome to the part 2 of the Hamoye Data Science January 2022 internship presentation series. Yesterday, we had 11 groups wow us with a splendid presentation, and I hope today's series is going to be as much fun as yesterday's. Just a recap of what happened yesterday. We had 10 groups: ADA Boost, Apache, a priori, Bayes, CAT Boost, classification, clustering, CNN, decision tree, and deep learning. Wow us with their presentations, and we'll be having the remaining 11 groups wow us today. Before we proceed, I would like to first introduce our judges for the day in the presence of Damilola Shobowale.
Yeah, thank you for having me today again.
Yeah, thank you very much for Dami for gracing this occasion. And also our second judge in the person of Shivam Singh Rathore.
Yeah, thank you so much for having me.
Without further ado, I would like to proceed to the order of the day, the business of the day, and call on our first group, which is group clustering, represented by Ritik Bola, sorry.
Good afternoon.
Good afternoon.
My name is Tunde, and I'm a member of the clustering group. I'm going to be doing the presentation for the group.
All right, Tunde, you have the stage, please.
Okay, let me share my screen. Please, you need to give me the privilege to share my screen. Hello?
You can go ahead.
Okay.
Hello.
Okay, am I audible, please?
Yes, you are. Tunde, before you start, you should know that you have 5 minutes to present. Make very good use of your time. And I'm going to give you a warning when you have 1 minute left.
Right, thank you.
Right, your time starts now.
Okay, good afternoon, my honorable panel of judges and my co-presenters and every other person listening to us. So my presentation is focused on global population estimates, and I'm presenting for my group called Clustering. Introduction. There has been tremendous growth in the size of the world's population in the last half century. Global population was around 3 billion in 1960. By 1987, in less than 3 decades, it had surpassed 5 billion, and there were around 7.6 billion people in the world in 2018. This growth varies greatly across regions. Since 1960, the largest relative growth has taken place in sub-Saharan Africa, where the population expanded from 227 million in 1960 to more than 1 billion in 2018, a nearly 5-fold increase. The second largest growth over the period can be seen in Middle East and North Africa, where the population increased more than 4 times from 105 million to 449 million. The scope and objective of this presentation is centered on region and age group analysis of population growth for years between 1960 and 2050, and also the modeling parts of data. This is a process key. First of all, we engage in the data acquisition. We got the data from Kaggle, and we cleaned the data. We further went through the exploratory data analysis, and we built a model for the data. Data acquisition. The database presents population and other demographic estimates and projections from 1960 to 2050. They are disaggregated by age groups and gender and cover approximately 200 economies, mostly saying 200 regions. This data set was kindly made available by the World Bank. So here we have our data contains 261 unique countries, out of which we carefully selected some key regions as our targets for analysis. So these regions are Nigeria, Ethiopia, India, Kenya, and every other part of Africa as a continent. So the reason why we actually did this was because while trying to analyze the whole world data set, we ran into some troubles visualizing the whole regions of the world. So we had to limit our visualizations to certain regions, which are the ones on the screen that I just mentioned. Okay, so while we were trying to do the exploratory data analysis, we found out that our data had lots of missing values, and especially from the left picture here, we can see that from around that 2016 to 2050, the missing values were greatly increased, where yellow indicates the missing value and blue indicates the values that are present in the data set. So after cleaning, we noticed that our data was free from missing values. And the method we used in cleaning our data was using the simple imputer, where we use the mean of each of the columns to fill its missing values. Exploratory data analysis. Okay, in this analysis, our focus are on three major objectives. So we shall be talking about the life expectancy at birth, the population growth of each region, and age group population growth. So here is the life expectancy at birth. Okay, so analyzing the life expectancy at birth, we focused on two major years because we have about 93 years in our data set. That was.
And you have 1 minute left.
Okay, all right. So here we saw that. So this is the percentage of the countries in the regions we selected for 1971. This for 2050. So from the pie chart, you see that Nigeria has the least life expectancy at birth in 1971 and 2050, having 7.22% and 7.12% respectively. And also the Middle East and North Africa region has the most life expectancy for 1960 and 2050, having the following percentages. Population growth of each region. So here we use the bar plot to visualize our data set where each of the population growths projection are on the bars, are represented by the bars, and the black lines, they are represented by the uncertainties in the estimates for year 1960, 2022, and 2050. Okay, here we talked about the age group population growth for male, and also we analyzed for female too. And we found out that.
Please round up.
Okay. So we went further to build a model for our data using the random forest regressor, the XGB regressor, the linear regressor, and we use the following metrics: the R squared, the MAE, the RMSE, and the RSS. So here, this is the code we actually want to get. So by the right of the screen here is the performance of our metrics. We can see that each of the performances for each of the metrics are stated besides the models, where we have the how to score, the MAE, the RMSE, and the RSC. In conclusion, we have critically perused a diverse set of mechanisms and analysis through which population growth is affected, ranging from life expectancy, population growth of each region, and age group population. Also, we built a model that can predict to a certain degree of accuracy values closer to the actual values. Thank you.
Thank you very much, Tunde, for that insightful presentation. Over to you, our judges.
Yeah, thank you very much, Tunde. Very good job done. Can you please move to the screen where you have the missing values, the visualization? Yes. So please, can you remind me? You said how did you do your imputation?
Okay, yeah. So when we were trying to analyze data, we found out that the missing values were great, and we couldn't drop the rows with the missing values. So what we rather did was we filled the missing values with the mean of each of the columns. So we found the mean of each of the columns for prediction, and we calculated the mean out of them. Yes.
Yeah, but do you know you cannot use mean for all the features? So essentially, what kind of features did you have? Were they all continuous features? Did you have any categorical features?
Yes. Okay. So for the data, we actually had non-numerical features and we had numerical features. The non-numerical features are the categorical features, which are the country names and the series names. So in handling the missing values for the category data, we use the most frequent values to fill in the missing values. But for the numerical, we use the mean to fill them.
Yeah, that's good. That's what I wanted to confirm. Okay, so let's quickly go to your modeling. Yeah, just the metric. Yes. So amongst this metric, which one are you sticking with for your regressor and why?
Okay, yeah. So when it comes to the metric, we can't really stick to one. The metric are just really used to help us know the performance of our model. So we only use the metric to really tell how good the model is performing. So I can't really say we can stick to one. What I rather say is that we have to see what they give us. We have to understand what each of them do, and then know how we go back to the data to
Okay, let me
run the
try
model.
to let me try to paraphrase. For this your use case, if you were to choose one metric and optimize that metric, which of these 4 metrics will you pick?
Okay, I'll be going with the RMSC. Reason being
Why?
that, okay, reason being that it's the root mean square error of the data set. So it handles the error, it squares them, and it finds the root mean square, and it's in a way it partially deals with overfitting of the data set.
So are you saying the R squared cannot be used for that same reason?
The R square can be used, but in most general cases, one cannot always rely on the R square method.
Why did you say that?
Because it actually deals with a lot of, because it deals with the residuals of the data set, the residual sum of squares and the total sum of squares. So using this, based on most practice that I've worked with using the R2 score, its performance really doesn't, though it's to a degree, it tells some evaluation of the data set, but using some other metrics too, we observe that it cannot totally be relied upon. So we use it with other metrics.
Yeah, it's fine. Thank you. That's all from me.
Thank you very much, Damilola. And thank you very much, Tunde, for that presentation. You may stop sharing now. Our next group to present is a dimensionality reduction group, which is to be represented by Bello, Abdulmalik, and Francis Alfred Michelson.
Good afternoon, everybody.
Good afternoon, Michelangelo.
I'll be presenting for the dimensionality.
Okay.
So maybe I want to share my screen now. Thank you.
Yeah, you may proceed, please.
All right.
Your time starts now.
So good afternoon once again, everybody. I'm here representing Dimensionality Reduction Group, and our project title is focusing on the COVID clinical exploratory data analysis. First of all, we need to go to the problem statement, which is why are we this project in the first place? So sometimes in 2020, the COVID-19 issue and pandemic took the whole world in lockdown. That scientists and medical personnel are clinical trials. There's a clinical trial community. So the COVID pandemic took everybody to lockdown to do a lot of their operations via very, very difficult. So after the lockdown and the pandemic, trial management now needed to consider how to restart these trials, how to come back on board. So the project description here is that we are studying the COVID trials data set, which we got from Cargo, and we are trying to explore the columns to understand the relation in order to be able to model accurate machine learning. So now the workflow started by first we got and then we had to clean the data, checking for anomalies, missing values, and a whole lot of them. Then the next one, dimensionality reduction, which refers to techniques where we just have to reduce the number of input variables, the ones that are not needed, that would, when we reduce them, we reduce the number of unwanted variables in the data set, we give the model the capacity to look better. Then we explore the data analysis, the relationships, and a whole lot of other things, how one variable affects the other, the data. So going straight to what we discovered. So first of all, when we have different columns, one of the columns was study results. And study results is basically about the activity of each of these trials on clinical government website. That's where we found data set. And we discovered that like 9.3% had no results available. So we moved on to, so when we visualize the phase now is telling us the level of operations while we are doing the clinical trial analysis. We are moving from one phase to another, and we discovered that the most important studies took place in the second phase. And we can see some
Yeah, I think you are breaking.
no result available rather. Hello? Bello, please, can you continue with the presentation, Bello?
Hello. Yeah, good afternoon.
Yeah, Bello, you have 1 minute left. Please maximize your time.
All right. So the thing is basically visualization presentation on the COVID-19 trials data set. Okay. So on this page now, what we have here is the data set contains different columns on. So for study type, we discovered that most of the study types were interventional and observational, in the sense that intervention is they assign they look for intervention, ways of directing tests, giving vaccines, and for hello.
Bello, please round up.
Sorry, am I audible? Hello?
You are audible.
All right. So as I was saying, so it was just a visualization on study types. We have more of intervention and observation, where they observe patients who have COVID-19. And on the interventions side, we had diagnostic tests, behavioral, device interventions, procedural interventions. Under diagnostic,
Bello,
things
please
like
round up. Round up.
it really just includes giving information through visualization about the COVID-19 trials data set. And EDA, the exploratory data analysis. Hello.
All right. Thank you very much, Bello. Over to you, our judges.
Yeah, thank you. So it is a very important topic of COVID-19 that you have worked on. So just a quick question, like how would you summarize your findings and what would you recommend after this analysis of the project? And the second question would be, what were the factors that you were having in your mind when you were dealing with the dimensionality reduction of the data set?
For the dimensionality reduction, it was more of domain knowledge on which columns would be needed for the analysis. So in the original data set, we had like 27 columns. We were able to bring it down to 12 columns just based on domain knowledge on which columns really would be.
Okay, so you are saying like just based on the domain knowledge, you just removed those columns. So
Yeah.
were there any kind of methods that you followed?
Sir?
Any kind of specific type
The
of methodology that you
reduction was
followed?
just based on reductions were just based on the domain knowledge. The data set contains more of text columns, a lot of descriptions on the old trials. So it was just domain knowledge.
So can you just summarize your findings? Because as I'm able to see, there is no modeling involved. Can you just
Yes, it was just
tell me about your
exploit data
findings from this analysis? It would be very helpful.
All right. So the findings are that most of the interventions given to COVID-19, given to patients involved in the trial process are just drugs, diagnostics, behavioral interventions. Behavioral involves, for example, women who are breastfeeding or women who are pregnant, breastfeeding support, group lifestyle enhancements. Those are behavioral interventions. For the device interventions, they were using digital device to assess or rehabilitate some of their cognitive functions that have been worsened by the COVID-19. For procedures, we had like abdominal cleansings and all, and we're able to see the countries that are going through the trials. At the top of that is US, France, United Kingdom, followed by Italy. And also,
Just a last question, like what were the factors that you think were responsible for the fast and slow recovery of the countries, according to your analysis?
the fast, I didn't get that, sorry.
Yeah, in the last part of the visualization, you have talked about the fast and slow recovery of the countries. Can you just tell
trial time by countries? Yes. We had the starting date of a particular, the data set contains starting date of a particular trial and there it was completed. Okay, there was that date duration. We now average over countries to see countries that take faster time to complete trial process than others.
Okay, thank you.
Thank you very much, Shivan. As a tip to other groups coming on, 5 minutes is more than enough time to go through your presentation. You don't have to speak on every single slide. Skim through the less important ones and go straight up to the important ones. And don't assume you have all day to do your presentation. So it's just an advice. Try and make the most of your 5 minutes. Our next group to come on board is group Gradient Boost, presented by Constance Aduse and Joseph Ologunja.
Good afternoon. I'm Joseph Ologunja. I would like to present for team Grad Boost. So I'll be sharing my screen now. Please tell me if you can see my presentation.
Yeah, your screen is visible.
Yes, I can.
Is it visible now?
Yeah, it is.
You can just see the slide.
Yes.
Okay, thank you very much. So I'm starting my presentation now.
All right, your time starts.
So I'm presenting for groups Grad Boost. Our scope is jobs and career, and we're working with a data set called the online job data set. All right, so these are a few members of my team, the team I worked with on this project. So our outline will include the introduction, the problem statements, the data sets, methodology, results, and recommendations we were able to make from our analysis. Am I audible, please? Hello, am I audible?
Yes.
Yes, yeah.
So our introduction, the demand
Your
for
slides, sorry,
Hello?
your slides are halfway. Could you make it complete, please?
Yeah,
How
put it
about
on
now?
full screen.
Oh, are they better now?
Yes, it is.
Okay, thank you. So let me just continue from the introduction. So the demand for job in the labor market has been continuously evolving over the years, especially with the advent of technology to help advertise job posting. So me and my team, we wanted to try and understand the
Yes,
needs.
sorry to
for
cut
the
you.
demand.
Sorry to cause you. We cannot see your slide. It's showing presenter window. This window is just for you. It's
Yeah,
obstructing
not
your
visible.
slide.
How about now?
Okay. Yes. Okay.
Okay, sorry. We decided to find out the demand for certain jobs and what professions are required for and the skills that was needed. The product statement, I want to find out what the jobs are in high demand, the skills that are in high demand, and if these skills have changed over time. So the data set we used was the online job data set. We got it from Kaggle, contains them 19,000 job postings, contain them about 24 columns of mostly textual data. And from the year 2014 to 2015, and the location is Armenia. The methodology we used was to explore the data with a Panda profile, which gave us an overview of the data. It gave us about 30% null values. So in our cleaning, we made some hypothesis that the job posts column in the data set was basically script online, and it was divided or processed to get the other columns. So if there are duplicates in the job posted columns, we need to remove that duplicate. And if there's any repetition in the year, month, company, and job posts and title, that means it's also a duplicate. So we use that to clean data. We also worked with each column separately with the title and required qualifications separately, so that we could maximally use the data set. So we basically use Python methods and to analyze the data set to get some results to answer the problem statements. And some of the results we're able to get include that there was a high demand for jobs, especially in March of the year. We saw that constantly throughout in the data set. Then there was also low demand for jobs, especially from September towards January, then also in April. Then accountant job, financial job related fields were maximally demanded for. And then language and Microsoft Office 2 skills were also required by many employers. So this is a visualization showing the trend per year. So we saw that 2012 had the lowest output demand for jobs. This shows the trend per month. As you can see, March here has the highest output. Then as I spoke, September going down towards January had a decreasing trend. Then based on the top jobs, we have accountant, chief accountant, we have software engineer, but basically more non-IT jobs were required than IT jobs, as you can see in the next slides. Over the years, the demand for jobs kept growing, but the non-IT jobs were more than the IT jobs. So I'll be speaking of distribution. So basically, some of the required skills included Russian language.
We have less than a minute.
English language communications, Microsoft skills were required often. English language skills were most required over the years, and other people required communication skills, Microsoft skills, and organizational skills. So this is some chart showing what was required for different jobs. So I'll just be going to my recommendations now. Some of the recommendations we made that for both IT and non-IT jobs, Microsoft skills were important, that any job seeker should attain fluency in English and other Russian languages, and targeted job acquisition should be done in March, and then internships are also required because of need for work experience. That is all. Thank you very much. I'll be taking questions now.
Thank you very much, Joseph. Over to you, our judges.
Hello?
Yeah. Yeah, very good presentation. Okay, first question. For your missing values,
Yes, sir.
can you reiterate what you did? You said you removed duplicates, correct?
Yes.
So what do you
yes,
mean
sir.
by you remove duplicates? Can you please reiterate?
So, like I said, the job posts column, basically the way the data was scraped online was just getting just the job post that was, like I said, the job post was scraped from a Yahoo mailing group. So that was used to process different aspects of the job post. That is title, company, about the company, the deadline, opening dates. So based on that, I think they use regex to do that division. So some of the columns in some other columns were very, very, they had a lot of emphasis. So we had to decide some columns that were required based on our objectives, which was the title column and the required qualification column, which would give us the title needed, the demand for job needed, and then the required skills needed.
Okay.
So what we did was just to remove as much of the, we had about 0.1% in the title column that was missing, and then we had about 2.5% in the required column, in the required qualification column that was missing. So we just dropped that and worked with about 80,000 plus columns to get out in our data set, in our analysis.
Okay, so in this your data set, what was your target?
Our target.
Yeah. Did you have any targets?
Could you please, I don't understand the question.
You mentioned the features now. What was your target? What did you try to predict?
We're trying to get the demand for the jobs, what was the most jobs demanded for, and then the skills that were required by employers for some of these jobs, and for was required over the years. And for some of these jobs, we also try to get required skills so that we could offer.
Yeah, I'm asking this because I did not see any modeling. You understand? And yeah, could you please explain why you did not perform any modeling?
I don't know.
Okay.
Most of the results we required from our objectives was also already answered without need for modeling. So I didn't know if modeling could have offered any more results based on what we needed.
Okay, so that was why I initially asked for your targets. But yeah, that's fine. Yeah, so that's all from me. Thank you.
Thank you very much. Is there any other question?
All right, thank you very much, Joseph.
Okay. I can stop sharing my screen now.
Now you can.
Thank you very much.
Our next group to be presenting today is Group KNN, represented by
give me the permission to share.
Represented by Sopan Latifa.
Hi guys, please let me enable Akshay to share. Okay, please show me. Can I start now?
Yes, my screen is visible.
Yeah, please go ahead.
Hi guys, my name is Sopan Latifa and I'll be presenting for Group KNN. We were asked to work on a data set, gun violence. Our data set was gotten from Kabu. It comprises of data from the year 2013 to 2018. Our main aim is to get insights from it. Here is our data frame. We can see that our data has more than 200,000 rows and 29 columns. So we had sufficient data to work with. We can also see that our data set has missing rows, which was as a result of missing incidents. So according to the author of the data set, we have to fill it in manually. To get the number of violence, we combine the number of people killed and the number injured. We also split the dates into year, month, days in order to get more insights in the data. Next slide, please. Here is what each row entails. In addition, our data set had no values, but for the analysis, we needed the date, number killed, injured, and place, which is available. So we included it in our data set. Firstly, we checked for the number of gun violence per year and found out that the number of gun violence increased on a yearly basis. As for 2018, it's like that because we had data just for 3 months. We check for the number of incidents per month and of every year, and we realized that the month of July had about 4.2 thousand incidents, while February had at the least number, which is 3.1 thousand. Here, we use a word cloud and a bar chart to check for the average number of gun violence per week, and saw that gun violence occur mostly on weekends, which are Saturdays and Sundays. We use the line plot to check for the trend of violence per month, and July seems to be the most violent month, and we can infer that this must be due to the fact that July 4th is celebrated as Independence Day in the USA. That's according to the data set. Checking the number of incidents by every state, the data revealed that Illinois had the highest rate of violence, while Hawaii had the least violence. In addition, we check for the number of incidents per 100K of state population, and the District of Columbia had the highest number of violence, while Arizona and Hawaii had the least. We use the word cloud to check for the most violent area, and discover that apartments, parks, and high schools were the most violent places. Looking at the gender of participants, we discovered that the male gender were like 6.5 times more than the females, though we have some gender not recorded. Analyzing the type of gun used, we saw that most of the gun used are not recorded. Also discovered that 14 gauge was used the most, while 28 gauge was used the least. We can also see that single guns are used the most, than on the other shots. We check for the number of guns used in shooting across cities in USA, and South Carolina had the highest number of shooting, while Wamley had the least number. We also check for the most serious incidents so far and discovered that Las Vegas recorded the most deaths due to gun incidents. Here is what the visuals for the violence. And we can see that the red part depicts where the gun violence occurred the most, while the white part are where it occurs the least. We took further insight by looking at the incident character per year and saw that the participants were trying to create violence by just leaving people injured and wounded and not killing them. And also in USA, there are 70,000 incidents which are of drug involvement.
You have 1 minute left.
And lastly, we analyzed the age group of the participants and those who fell victim of the violence, and found out that most of the age group are within 18 and 25. This is quite insightful because we see that, and we can see that government are taking action to curb gun incidents. In some states like California, they are really trying to do that, while in some other states they are not. In conclusion, we can see that gun violence have high occurrence on weekends, and this may be due to the fact that people are at home or in their leisure park. Most participants of gun violence are male. Illinois is the most violent state. The month of July is the most violent month, and this is due to the fact that July 4th is Independence Day in USA. And the age bracket of the participants and victims are within the range of 18 and 25. So what are our recommendations? We think government should increase security vigilance during holidays and weekends, or mostly during national holidays. And we also think government should create job employment for people mostly within the range of 18 and 25. Thank you.
Thank you very much. Over to your judges.
Yeah, thank you. So can you just move to the missing values slide?
All right.
So just before that, I think you mentioned something about that you guys manually handle the missing values. So
Yes,
how
yes.
did you did that?
This was a recommendation of the author of the data set. Means on the Kaggle, you can host a data. So the data author said that he has failed to miss this row, fill this row. That's why he told us to manually add the rows.
Okay. And
yes,
the other question would be, like can you just move to the trend of violence per month?
Yes, just wait. This, yes.
Yeah. So you guys have did a very good job by giving a EDA analysis. But the point is
Thank
that
you.
you are giving
Yes.
us a lot of information, but what I am not able to find is a kind of modeling sort of thing. So can you explain me like what stopped you from getting into modeling stuff?
Actually, this is the just information about the dataset, means what they have given us, this the state, address, and killed. So if we decide to get a target of killed people, we can just get a trend. So we can't just predict that within 10 days there will be a shooting going to happen and this much people are going to kill. So that clearly means that you are actually involved in the participants. So there is no actually a target variable here.
So just like the last question
and
would be, suppose I am a US authority, and what would be your final recommendations and how will you improve the project? Suppose if I want to take it to the production, what would be your recommendations or what changes will you do?
See what we have got, that forget about this two age group, because we have just 3 months of data for this. We can see that the violence is increasing by the year, and on the July and August this is increasing because 4th July is celebrated as the Independence Day in the USA. So they may increase the security on those days. And what we have got, that see, we have got the visuals of the area, so they can increase the security in this area. Again, we found out where the problem actually is. See, the participant is actually most of the peoples are just injured, so they just want to create the violence. And we have discovered that there are factors like drug involvement, home invasion, domestic violence are also there, which are the causes for the violence.
Okay.
And another thing that we found out that this age group, this is the mainly reason for the unemployment. See, they are the people who are the same group, they are killing the people of age group between 18 and 25. So that is the reason for unemployment. And another thing we have got, that the government is increasing the laws, and where the violence is not happening, they are also decreasing. You can see that here. This is one thing. And another recommendation was holidays. Within holidays, the violence increases. So there is a recommendation for people that the countries like this you can go to those states for holidays in the weekend. That is our recommendation.
Okay. Yeah, that's a good thing. Like you guys have tried to relate it to the real world problem, and you guys have not been just mechanical, just giving input and getting output. That's very good. Yeah, thank you.
Thank you so much.
Thank you very much. Damilola, do you have any questions for him?
No, not any. Very good presentation.
All right, thank you.
Thank you so much, sir. Should I stop sharing?
Yeah, you can. Our next group to present today is group KNN, represented by Soban Latifat.
We just done it.
Oh, sorry. Light GBM group, represented by Ankita Kandalka.
Yes, sir. Should I share my screen?
Yeah, please, you can go ahead.
I hope my screen is visible. Hello.
Yes, your screen is visible.
Okay. So hello all. I'm Ankita Kandarkar from Light GBM Group. Today I'm going to discuss our Premier project, which is based on a data we received, which is a Japan trade statistics. Moving on to the data description. This is the file for year 2020, and we have the several columns into it. So first column indicates the index, second column is export and import, whereas export indicated by 1 and import indicated by 2. Third column is year, fourth column is month, fifth column is year and month. Country, HS2, HS4, HS6 and HS9 are decoded by the numbers, whereas HS2 and HS4, 6 and 9 are the product clusters which are traded in the Japan. Q1 and Q2 are the quantities, and the value is the revenue of the trading revenue. So our problem statement is, as a data scientist, here our role is to analyze the data set and generate the insights and building the machine learning model to predict the future outcomes. So methodology we followed is the data collection, data cleaning, exploratory data analysis, and model building. So we collect the data from the Kaggle site. As our data set doesn't have any missing values, so this step is not taken. We perform the EDA analysis and model building. Moving on to the EDA. So this graph shows the products from the HS2 cluster. So here the 84 suggests that the machines are machines give the high trading values in Japan. From the HS4 cluster, the highest trading values are given by motor cars. From HS6, the highest coding values are given by petroleum oils. And HS9, the highest trading values are given by chemicals. This line plot shows that the year 2020 has the highest trading value in the Japan. So we analyzed the data. We first did EDA on the year 2020 dataset. So year 2020, the month March has the highest trading values and month May has the lowest trading values. So we also analyzed the trade market. So China is the greatest trading partner for the Japan. In the year between 2017 and 2021, we also found that the China is the only good trading partner of Japan. So moving on to building a linear model, we performed a correlation analysis between the columns, and we found out the Q2 and the revenue value has the good correlation with each other. So we use them as for a linear regression model. This shows the relationship between the features and target variables. But we got very less R2 score. That's why we are not, our model is not good for the predictions, as we concluded. So our conclusion includes that after analyzing the Japan data sets, it was found that China is the biggest trading partner of Japan in both imports as well as export. The highest trade value was noted in the year 2020. The most traded products in Japan includes machines, motor cars, petroleum oils, and chemicals. After training the 70% of the data, we obtained a very poor R2 score, and poor correlation suggests that our model is not good for the predictions. Thank you.
Thank you very much, Ankita Kandarkar.
Yes.
What's your advice?
Yeah, so good presentation. Can you please move to the modeling, to where you have the R2 score? That's slide 19. Yes. So yes, so did you try other regressors?
No, sir, we only tried only one regression.
Why didn't you try others?
Because
Since
our data is completely loaded, decoded, because we have only 3 columns which are values, which have already values, and rest of the data is decoded by the numbers, so we couldn't perform any modeling part for that.
I did not get that. Can you reiterate, please? Can you repeat yourself, please?
So our data is mostly the decoded data.
Okay.
And only 3 columns has actual values, as you can see here.
Okay.
Or rest of the data is the decoded. So the country is given, that is also the numbers are decoded. The product clusters also decoded. That's why we couldn't model our data.
Okay. So from this project now, can you tell us the scope of this project? Can you tell us your findings and can you tell us your recommendation? Most especially the recommendation. So what can you recommend after all these findings?
So after this, we can, after seeing the data set and analyzing the data set, that it was found that the China, United States of America, and Taiwan are the biggest export trading partners of Japan. And we couldn't get the data for 2021, but year 2020 has the highest revenue values among the years. And the most traded products are machines, motor cars, and petroleum, oils, and chemicals.
Yeah, so what I mean is, if I were to be a business executive now, how do you sell what you've done, your findings? How do you pitch it to me?
So I don't know, sorry.
Okay, that's fine. Thank you for your presentation. Yeah, thank you. Good
Thank
job.
you.
Thank you very much, Damilola. Antika, you can stop sharing your screen.
Yes, sir.
All right. Our next group is the Logistic Regression Group, represented by Unyeka Okonjian, Shomgi Sanya.
Hi, is my screen visible?
Yeah, it's visible. Please proceed.
Okay. Good afternoon and good evening, esteemed judges and my fellow interns. This is Team Logistic Regression, and the topic of our presentation, our premier project for HDSC Winter Cohort 2022, is weather prediction for a city in Israel, Tel Aviv. Now, this presentation contains an introductory problem statement of our project, followed by the process outline, and finally we summarize with the conclusion. Today, Onyeka and I are going to take you through this journey. We were assigned hourly weather data that records different attributes such as temperature, pressure, etc. for a span of approximately 5 years. Our goal was to predict whether the sky is clear or not using those attributes. For this, we used supervised machine learning models and time series forecasting to predict the weather for future dates as well. The entire process flow has been divided into these 5 parts. We start with data collection and end with model deployment. Now, this data set was taken from Kaggle. The dataset contains 5 years of high temporal resolution data of various weather attributes such as temperature, humidity, air pressure, wind speed, and wind direction. This data is available for 30 US and Canadian cities as well as 6 Israeli cities. Initially, our target variable, that is the weather description, had multiple categories, but for the purpose of yielding better accuracy on the data, we decided to club them into 2 broad categories, which are sky is clear and sky is not clear. After going through the data sets of every city, we decided to go with Tel Aviv due to the fact that it was one of the most balanced data sets out of all the other cities. Here, the weather column is actually the weather description, which is our target variable. Now, these are the distribution plots of all the features. While humidity follows a roughly negatively skewed distribution, wind direction does not really follow any distribution. For data wrangling, we decided that since null rows accounted for less than 5% of the data, they should be dropped. For any other missing value, the median of that respective column was chosen as a replacement. Additional features were created by grouping the values by date for each feature. This was done to increase model robustness. Next, the date time column was split into its constituent components. Lastly, it was observed that both wind speed and pressure had significant number of outliers, and hence they were also removed. Now, from the correlation matrix of both the original and added features, we can see that the variables have very less correlation between them, with the exclusion of wind speed and wind direction, which has a correlation of about 0.56, and temperature, average temperature, which had a high correlation of about 0.88. Now, we had our pre-processed data set trained and tested with various ensemble models like decision tree, gradient boost classifier, like GBM, XGBoost, CATBoost, etc., among which random forest classifier had given the best accuracy. The confusion matrix generated shows that random forest classifier had the lowest false positives and false negatives amongst all the other models tested. Now, we also tried to forecast the weather attributes for future dates and deploy our ML model on those attributes to get the weather description. We moved forward with Facebook's Prophet library because of its modern and more intuitive approach. We finally were able to deploy our model via Streamlit, which gives us the hourly weather predictions for all the days from 1st December 2017 to 30th November 2022. We also deployed our model via Flask, which predicts the weather once the user provides the feature values. Now, this project illustrates how different weather attributes can be used to predict the weather. It was our aim to predict weather with as much accuracy as possible, hence making it easy for lives or livelihoods that are dependent on weather make appropriate planning using the weather prediction model. And now Onyeka will show the deployment of the model.
Hi, good afternoon, everyone, and good evening also. Shibangi, can you put on? Yes. So this is the first deployment, which we did via Streamlit. The first step is to load in the test data, which we got from the forecasting. So once we load the test data, which is from 2017 to 2022, for every hour of the 5 years, we run the prediction, and then we see the outputs basically for every hour of the next 5 years from 2017, basically. So that's what the Streamlit app does. And then also after the result, we can see a pie chart for the next 5 years, which shows that there's a kind of balance between the sky is clear and sky is not clear. Next, we move to the Flask app. The Flask app enables one to enter the figures individually and then obtain a prediction of the weather outlook. So if you click on that, it gives us a figure. It gives us a prediction rather. Let's give us a second, please.
I'm sorry, my internet speed is running low. Yeah, there it is now.
All right. Yes. So as you can see, once you enter the figures, it gives us an output, which says the sky is clear. So with this app, anybody can enter the figures and then obtain a prediction for each hour of the day, basically. Thank you very much.
Thank you very much.
And that concludes our presentation.
Thank you very much. And now over to our judges for their comments and questions.
Yeah, thank you. Good presentation. So I would just like to move to the EDA part. Yeah. So what were the factors that you choose only the sky is clear and sky is not clear? What was your thought process?
Well, there were a lot of other factors. I mean, there were a lot of other descriptions like cloudy, rainy, etc. But there weren't a lot of values for them. So in order to get a more balanced data set to better train it, we limited ourselves to sky is clear and sky is not clear.
Okay, when we say sky is not clear, what does it signify? It means like it can rain?
Yeah, it could be a lot of things. It could be rain, storm, hailstorm, lightning, thunder.
Okay. So can you just show me the data set, the initial data set that you chose? You in the presentation, you told like you chose a portion of the data set.
Yeah, we didn't include that in the presentation because we only included the ones that we worked on. That was for Tel Aviv.
Okay. So like after your analysis, what would be your recommendations? Suppose I'm an authority, what would you recommend me, or how would you pitch this to me?
Well, the weather prediction gives us whether the sky is clear or the sky isn't clear. So we can use that in case there is an emergency and we need to know how the weather is going to be in order to work. For example, I'm in a construction working site. So if the weather isn't very clear, then there might be problems to send construction workers out there. So this will somewhat help to prevent some accidents.
Okay. Can you walk me through your deployment process on Streamlit?
Onyeka, would you like to take that question up?
Oh yeah, I can do that. Can I share my screen, please? Shubangi, can you stop sharing?
I've stopped sharing my screen.
Okay. All right. So the first, let me see. The Streamlit app is this one. Okay. So basically, what we did first of all is create a kind of file in which you can upload in a file basically, which is the output of the forecasting, which we did using the Prophet model. So I will just load in the test data.
So this is the raw data or pre-processed data?
No, this is the forecasted data that I will load in right now to perform the prediction. Yes. So basically, I'm loading the forecasted data. Forecasted data basically is from the year 2017 to 2022. So once I do that, it's loading. It will display the data set for us to see. All right, so we can see here basically it's the forecasted result from the year 2017 to the year 2022. Basically, so if I run
November
prediction,
2022 to be exact.
Yeah, exactly. So if I run prediction right now, it gives us the output for each hour of those years basically, which you can see here basically. So let's say on the first day of December 2017, the sky is clear which is at exactly 1 hour. At the eighth hour, for example, the sky changes to sky is not clear, which can be determined by a factor, whether it's unstable. And also we decided to plot a pie chart of this output for the next 5 years, which you can see here. So this is the Streamlit app.
Got it. Very well. Thank you.
Yeah, so one question. Why did you decide to impute with a median? Why didn't you try mean?
We use median to replace the missing values because of the outliers. Well, there wasn't a lot of difference between the mean and the median after removing the outliers, so they would have given us very similar outputs regardless. But in the beginning, since we didn't want the outliers to affect our data set, we used the median.
All right, very good. Thank you very much.
Thank you.
Thank you for this, and thank you very much, Sanya. You may stop presenting now. All right, the next group to present is group ID3. Group ID3, represented by Mamata Kalali Paitara and Gunupudinaga Monica. Hi.
Is my screen visible?
Yeah, it's visible.
Yeah, can we begin?
Yeah, please go ahead.
Yeah. Hello everyone, this is Maunika and Mamata. As a part of Premium Project on behalf of Group ID3, today we are here to present our topic, Mortality by Age and State in Germany from 2016 to 2021, and the scope of this project is Health and Medicare. Let's begin with brief description and overview of the project. In this project, we take a look at one of such countries, Germany, and visualizes the mortality rates by age, month, and state pre-COVID and after COVID. The data used in the project is obtained from Federal Statistical Office, which contains the death counts categorized according to age group, state, and month. The timeline of the dataset spans from March 2016 to Feb 2021. Let's begin with data pre-processing. As we all knew that data pre-processing is converting the raw data into processed state to fit any model into it. The dataset was originally in German language and was mapped into English language for the purpose of our project. The columns, too, were equally renamed to convey better the data they hold. The dataset contained a number of Excel sheets and the necessary sheets were extracted for analysis. As you all can see that the original data was originally in German language and after pre-process the data is in readable format. This is the timeline of 4-year period and the blue color indicates that before COVID and orange color indicates that after COVID. Well, using Matplotlib and Seaborn libraries, we visualize the death counts by age groups from 2016 to 2021. It can be observed that in the first 2 years, from 2016 and 2017, the age groups with the most death count is age 60. In the succeeding years, we see a slow overtake by age 50 group. This is the most apparent in the year 2020, in COVID year. Generally, death count is high for age groups 50 and above with counts of about 1,17,000 deaths per year and reaching as high as 1,90,000 deaths per year in 2020. It should be noted that in year 2021 only contains data from January to February, hence the generally low count across all age groups. From the adjacent graph, we see that there is a drastical increase from age 80 onwards, but after age 90, the mortality rate starts decreasing. Similarly, we can find that there is a relationship between death count and particular month in subsequent figures. And further slides will be carried out by my friend Mamta.
Well, as my friend already told that we have grouped the data by age group below and above 65. Here we have plotted a horizontal bar between state and death count. For the age group below 65, we can observe for all the states that the death count is below 2000 except for North Rhine-Westphalia with a death count slightly above 2000. After that, Bayern and Baden-Württemberg have highly death count. In other states, the death rate remained constant. In the age group above 65, the death count is higher in all the states after COVID. This can be clearly seen in states, namely North Rhine-Westphalia, and it has an approximate death rate of 16,000, followed by Baden-Württemberg. Next. Here, when we plot a graph between death and the state per 1 lakh population count, we can see that the death rate has increased moderately in Berlin, Bayern, and Bremen. For every 1 lakh, the death count is less than 20 for these states. And in the age group above 65, the death count is far higher. And the state that is most affected with COVID-19 is Sachsen, followed by Mecklenburg and Brandenburg. Next. Here, when we plot the graph between death by state and population density, we can find that even with the smaller population density, the states like Sachsen and Sachsen-Anhalt has highest death toll, that is above 130 per month. Here we can also make a small note that being the capital of Germany, Berlin has a relatively low death count. Next. Through this data analysis, we can observe that there is a rapid increase in death rates across all the states of Germany, specifically in older age group. Next. So according to WHO, we can reduce the effect of COVID-19 by following some preventive measures like maintaining social distance and wearing face masks in public places. The people with cold and cough are also advised to isolate themselves to reduce the effect of COVID-19. Next. In conclusion, we have gone through the data and studied death rates in Germany over a period of 4 years, and we observed the fluctuations in death rates in different age groups in different states and the effect of population density on the death rate. Next. These are the references, and next, and thank you.
Thank you very much, Group ID3. Over to our judges.
Yeah, so very good presentation, and I have just 2 questions. So the first question, this project is more of analysis than modeling, correct?
Yes, sir. The main aim of the project is to perform analysis, data analysis.
Okay, very good. Can you move to your slide 3, where you have the data preprocessing? Yes. So what do you mean by discarding unnecessary columns?
What was the question? Can you please
Yeah, I said, what do you mean? Can you please explain to us what you mean by discarding the unnecessary columns?
like we pasted a few, like it was a sample, but we like pre-processed everything. In the original data set, they were basically we got 1 or 2 columns and 1 or 2 rows and 51 columns. So we processed everything. Basically, it was in German language. So we pre-processed into readable format. Like in the pre-processed dataset, we can see that year, age, January, February, March. Like we pre-processed it, the raw data into processed state for better understanding.
Yes, I understand, but just as we can see, you said discarding the unnecessary columns, so that's why I'm asking this. So, okay, let me just try to rephrase. How did you undo the missing value, this NAN? How did you undo them?
Okay, sir. Here we can see that in the first original data set, the last column is unnamed 15, which is having mostly NaN values. So it is not necessary. So we thought of removing that column. And
Basically, when we did outline, like when we plotted outlier, like there were not that much outliers, so we tried like to remove everything using drop NA function, so that the analysis could not affect that much.
How many percent of your data sets were the missing values? The missing values were how many percent of your data sets?
Like if we consider 100%, the missing mostly it got like it was like 20%, like it was not that much, so we simply dropped everything for better analysis.
Okay, so you are confirming to us now that you dropped 20% of your data sets. Is that what you did?
Yes, probably.
And do you think dropping 20%, do you think that's efficient in your analysis?
Well, in this case, we thought it was good enough. Like we were not predicting anything, so we just analyzing. So it was good enough to drop. So we thought in that way, dropping is better than.
Yeah,
So in my point, I just dropped. Like it was
it's fine. Thank you
cool.
very much.
Yeah. Any more questions?
Yeah.
I
Thank
just
you
have one
very
question.
much.
Yeah, please.
Yeah, you told like you converted German language to readable format. So how did you achieve that? I'm just struggling over that.
Okay. Like we tried doing in online before writing any code, like in writing any code in Jupyter. Later on, we researched and we tried to do that using dictionaries. Like we mapped everything.
Okay. So like for
Yeah.
every German word, you map to something in English. Is it like
Yeah,
that?
yeah. That's the same thing we did. Like we mapped for better understanding for ourselves.
Here we have
Okay.
mapped the months with the English month, German month, and the state.
Okay then. Yeah, thank you.
Thank you. Can I stop sharing my screen?
Yeah, you may.
Yeah, thank you.
Thank you very much. And thank you also our judges. Our next group to present is Group NLP, represented by Fatima Al Hassan and Ogunlana Oluwase.
Good afternoon, everyone. Good day, everyone. Can you hear me?
Yeah.
Please, I would like you to make Fatima a host, please.
Can I start? Sorry, good afternoon, everyone. Can I start the presentation, the slides?
Yes.
Okay.
Good day, everyone. Good day, the panel of judges. Good day, Amuye. Good day, the co-presenters and my fellow colleagues. I and Fatima Al-Hassan will be presenting on behalf of Group NLP, and our topic is foreign exchange. Next slide. Next slide. Now, this is the outline of the whole process: problem statement, introduction, objective, methodology, results, conclusion, recommendation, then the teams involved. Next slide. Now, introduction. Foreign exchange or forex rates is the value of one currency in terms of another. The foreign exchange market determines forex rates, which often fluctuate based on transactions between traders. For instance, the foreign exchange rate of Naira to dollar is 415.76. This implies that it takes 415.76 Naira to buy $1. Next slide. Next slide. Fatima, next slide. Next slide. Next slide. Fatima, are you there? My God. Hello. Hello.
I can hear you, sorry.
In the absence of Fatima, we did analysis of our data where we get to know that our data set contained 5,217 rows and 23 columns. Then we have 198 missing values, which is approximately 3.8% of our old data. Then the objective is to train a machine learning model to predict future exchange rates using time series analysis. Then to obtain a broader view of foreign exchange pattern of different countries. Next slide. Next slide. Now, thank you. Now, from this chart, we got to know that UK, which is the greatest pound sterling, have the highest in terms of dollar, like highest value in terms of dollar in exchange rate. And we can see that there's a high increase in towards the end of 2007 and early 2008. And that was because UK experienced an economic recession during that time. And towards the end of 2016 and early 2017, we can see that there's a low value of Great Pound Sterling. And that's because there was British exchange clamor during that time, which made the Great Pound Sterling to come down, to reduce, like to fall. Next slide. Now, then we did a visualization using Matplotlib to check for the rate of change of the value from year 2000 to year 2019, which is the span or lifespan of our data. And we can see that Switzerland, Swiss francs has like increased over the years, with Brazil, which has never, like does not really experience improvements over the years. Next slide. Then from our exploration data analysis, we discovered that Denmark and Euro have a perfect correlation. This is due to the fact that there have been all this referendum of a thing that maybe they should spend Euro in Denmark, which they kick against. And in fact, in some places in Denmark, from research, we got to know that there are some shopping malls where you can even spend Euro. And that's how we can see that there's a strong correlation between Denmark and Euro, like Denmark currency and Euro. Next slide. Then, so our forecasting, we did autocorrelation to check for the correlation of the values, because we'll be using time series data set, of which we use 4 different countries to build our model. These 4 different countries include UK, New Zealand, Australia, then Japan. Next slide. Then we build our model using Facebook prophets, and you can see from our results, like for Great Britain pounds, we can see that our mean absolute error for the every process is 0.03, and the mean squared error for GBP is 0.013. Then for New Zealand dollar, you can see that the mean absolute error is 0.078, approximately 0.079, and the mean squared error for New Zealand dollar is approximately 0.0071.
You have
And you
less
can
than
see
a
from
minute.
okay, you can see from the picture that the model actually really did well. Next slide. The same thing for this. Then the conclusion, the foreign exchange market has a direct impact on wages, cross-border investment, and the economic as a whole. Financial institution, company, government, and other institutions use this market to adjust their currencies. So this study proposed a means of utilizing data science technology to evaluate and predict source trend within countries' economy relative to the US dollar equivalent. Next slide. Recommendation, more ideas such as difference between the average of years can be done. Application of log transform can be encouraged because we used ADF testers to check if the data set is stationary. So we can try log transform in order to make sure the data set is transformed. Then we can also apply machine learning model like linear regression, random forest by doing shifting and lagging. Next slide. So thank you. The NLP team is comprised of different members, blah, blah, blah. Thank you. Next slide. So any questions, sir?
Thank you very much, Team NLP, for a very good presentation. And you were right on time. Over to you, our judges.
Yeah, thank you. So can you just move to the missing values part? How did you manage that part?
For the missing value data, we don't actually include it here. Actually, we have 3.8% of the missing value data, which is 198 samples from the whole data set. So we actually dropped the missing value due to the fact that most of the missing value occurs during the first day of the week, which is Monday. And we all know that foreign exchange markets happens during the week, which is Monday to Friday, and weekend, there's no foreign exchange market. So having a no value, like having a missing value in the first day of the week, we cannot just replace it with the value for Friday, neither can we just impute it with mean value, considering the fact that it's a time series data set. So, and now, based on the fact that it's just a minor quantity, approximately 3.8%, so we decided to just remove the missing value in order to perform our analysis.
Okay. So you were talking about like the Facebook profit library. So why don't you try any other models?
Actually, due to time constraint and all that, that's how we included it in our future works that we would love to try different models in order to test the performance with Facebook Prophet. Another thing that made us to use Facebook Prophet is based on the fact that we discovered that our data set is not stationary, and Facebook Prophet work very well with non-stationary data sets.
Okay. So what would be your recommendations or the findings of the project?
For the findings, it can be used for countries in order to know when the economy could be strong, and in order to know their future forex exchange, in order to like try to stabilize the economy and not let it have negative influence on their foreign exchange currency. And it can also help investors to like know the type of currency to buy and when to sell it, and which will enhance them to gain more profits.
Okay, thank you.
Yeah, so
Any other question?
yes. Can you please move to your model building slide? Yes. Yeah. So you said your model did well, but looking at these images, can you say your model is closely following the trend? Can you say your predicted value is closely following the test value?
When looking at data sets, I will not say it's actually following the trend, but it's actually trying to understand the variance. Like we can see that the error is the lower, like we know that the lower the value, the better. And we can see that the model is not actually following the trend like that, which we would like to like improve on, maybe by doing feature engineering or something of sorts.
Yeah, so that was what I wanted to ask next. I wanted to say, okay, so how do you intend on improving this? So feature engineering, what else do you think?
Sir?
I said, so yeah, the improvement, feature engineering, what else do you think you can work on again to improve the
So we think of including feature engineering, then also trying to make the data sets stationary, like doing log transform in order to make it stationary, and which will help to enhance the model performance.
Okay. Yeah. So last thing, and this is just like It's more of a correction. So when you are presenting, you don't use the word blah blah blah. So rather you could say, rather you could say and so on. So yeah.
All right.
Yeah.
Thank you,
So
sir.
yeah,
Thank you.
yeah, that's all from me. Thank you very much. Yeah.
Thank you very much, sir.
Thank you very much, Tim. NLP, that was a very good one. And I must say, feature engineering is a good thing to do, but always take note of the cost of dimensionality. So you don't have more training features than observations. Just a quick one. All right, on to our next group, ACA, which is to be represented by Omotosho, Olamileko, and Abdulatif Ogundipo.
Okay. Good evening, sir, or good afternoon, good day.
Good day.
Okay. I'll be sharing my screen now.
Yeah.
Can you see my screen now, sir?
Yeah, your screen is visible. You can proceed.
Okay. Good day, everyone. This is Omotosho Olamileko presenting on behalf of Team PCA, and our project is classification and prediction of dementia. And so this is what I'll be discussing today. So dementia is actually a cognitive dysfunction, and it can be treated. There's no cure for it, but it can be treated earlier if detected. And the symptoms of it include forgetfulness, limited social skills, and thinking ability. And on the long run, it can affect the person judgment and daily function. So our main goal as a team is to predict the chances that a person will be having the dementia and the probable type of the dementia the person will be having. So our data was sourced from Kaggle, and we have 373 entries and 15 columns, of which only 2 of the features have missing data. And these some of the data collected include the group, the number of visits to the hospital, the testing delay, the gender, the age, the educational status, the social status, and the some other minimum states examination. Okay, moving to the exploration, we can see that from here the age group, majority of dementia cases are within the age of 70 to 80, and also the correlation with them. And also it can be clearly stated, shown from our analysis that the minimal mental state examination, the higher it is, the lower the chances that the person will be demented. And this has a higher correlation with our modeling. So moving on to the feature engineering, these are basically the step we took, because we actually perform one-hot encoding, then we drop some unimportant features, then missing values, then we resampled it, then we perform standardization and normalization. Sorry. So yeah, this graph is actually showing the difference between the original distribution and the imputed distribution after our normalization. So moving straight to our modeling part, basically in the modeling, we did a cross-validation to avoid overfitting. Then we actually did data parameter tuning using research. Because of the size of our data, it won't be computationally expensive. So we actually used research. Then we tested the models on different models like logistic regression. So logistic regression was actually our base model. Then we used gradient boosting classifier, then random forest classifier, decision tree classifier. And basically the best was random forest. So from our random forest, after hyperparameter tuning, we had an F1 score of 0.9. And 0.9 is actually the F1 score is actually a combination of the precision and recall, like the average of both of them. So then we move on using the same random forest for our prediction on the probability of the dementia. So basically the limitation we had was small data sets and the imbalance class. And we handled, we took care of this by doing resampling, and it actually helped our model. So in conclusion, we actually chose F1 score as our metrics to check the accuracy of the model, and this actually did a very good job. So we can actually deploy this model in the healthcare parts, and it can help detect dementia in the early stages, and the treatments can be taken on to avoid losing our loved ones and relatives. So these are my team members that we all did this great work together. Thank you very much for listening. I'm ready to receive the question.
Thank you very much, Omotosho. I would definitely love to use your model so I can know when I should be expecting dementia in my old age. All right, over to you, our judges.
Thank you, sir.
Yeah, so very good job. No question from me.
Wow, thank you, sir.
Okay. Yeah, I just have one question. Can you just move to slide 9?
Okay. Sorry, sir. It's not numbered. Can you just tell me
Yeah,
where
the feature engineering.
Okay. Yes, sir.
Yeah, just before that.
Okay, sir.
No, go back.
Yeah.
One more.
This where the
This
feature
basically
engineering.
slide 9. Before modeling.
Before modeling. Okay. Yeah.
Yeah, can you just explain me this graph?
Okay. In our data sets, the missing values that we add, we actually use median to fill in the missing values, because the values, the missing values are actually in social economic status and the minimum mental state examination, which are ordinal data, and we cannot use mean to fill them. So we use median, and this actually show the curve of well before the missing values and then after filling in the missing values. This is basically what is in this graph.
Yeah, okay. Thank you.
Yes.
Thank you very much.
Thank you very much, sir.
All right, you may stop sharing your screen now. On to our next group Random Forest, represented by Ayush Trevor and Didion Oba.
Hello, sir. Am I audible?
Yeah, you're audible.
Okay, just a second. Let me share my screen. Can you see my screen?
Yeah, your screen is visible. Please go on. You have 5 minutes.
Okay. Also, I have shared the link for our deployed website. You can see. Okay. Okay. So, I am Ayush Verma along with Gideon Oba, and we'll be representing Team Random Forest. And our project was to predict the gold price, the adjusted, closing of the gold price. This is our team. So let's, before we understand the modeling, let us first understand why is gold prediction important. So since the old ages, gold has had a very tangible value. People have been using it as a currency. In fact, even today, central banks use gold as collateral for repayment of foreign debts. And also, whenever there's inflation, they dilute gold to balance it out. So, if there was a way to predict when the gold price will go up or when it will go down, it can help not only investors like me or big banking institutions, but it can also help countries, right? Because they'll know when to dilute it or when to buy or when to sell. So this was our aim. So we deployed, so Team Random Forest, we deployed a machine learning model to predict the future price of gold. So this was a process flow. We started with data cleaning, then EDA, then feature engineering, then modeling, and then deployment. And I now have Gideon, who will explain you the data cleaning and EDA part. And then I'll meet you for the feature engineering part. So Gideon, you can take it from here.
Thank you very much. Next slide. So our data was gotten from Cargo, sourced from Cargo, and the feature sets contained various intrinsic prices, such as oil price, the Standard & Poor price, also the stock price of different valuable metals. Our target was the adjusted closed price. Our data set contains 1,718 rows and 81 columns. Within these 81 columns, 80 were numeric, but the remaining column was a date, which was date and time.
if you notice in the heat mark when you left, okay, that's there. If you notice in the heat mark, go back, please. You will notice that our data set didn't have any null values, as you see from the heat map. It's a Christian value showing that having a correlation of 0. Next slide. So the EDA, basically what we want to get, we want to understand what our data, what's the relationship between our features and our data sets. So we performed some correlation analysis and some statistical analysis. In our data sets, we found out that the SP and the DO had the biggest index. Hence, we wanted to see the correlation with our target, which is the adjusted close value. And when we did this, we saw that these two values, which is the SP and the DO, had high negative correlation, positive correlation of 0.9, but had a negative correlation with the close. Next slide. Now we plotted a graph showing our adjusted close price of gold. You can notice that the highest values comes at the end of 2013, like December 2012, and the lowest comes at the end, that is 2015 to 2016. That is when we had the lowest values. And also plotted a correlation map with all the features, in which most of our features performed above 0.8%. Next slide, please. We tried to plot the daily return of the adjusted close features, and we can see in the left image from 2011 to 2013, the highest being in 2013 with a value of 5%. And we can see that in that circled area, the price kept on fluctuating till 2013, and the price fell down to 2018, where it stayed at the all-time, where it remained low. We also plotted a graph with various of our related features on the right, and we saw that SP had the best performance index over the years, while gold was the second best. Next slide, please.
Okay, so I'll be taking on from here. So we did feature engineering. We used multiple methods.
You have less than a minute.
So we used multiple methods, but eventually we came down to 2, which was univariate and extra trees classifier. And these were the 8 features that we selected. We moved on to modeling, where we used 4 models, and random forest came out to be the best model. So these were the predicted values and the actual values versus the predicted values for the 4 models. And eventually we deployed the model. I've already shared the link. You guys can access it through this URL. Now we had a time constraint. Also, our data set was from 2011 to 2018. So our aim would be after this to increase the data set from 2019 to 2021. And we'll like to see how it performed over that. Also, we would want to, since this is gold, and we also had S&P and Dow. So we'd also try to see what S&P and Dow, we would like to predict the values of S&P and Dow as well, also, and use an API for it, if possible. We did not have enough time to implement an API here, but we would like to do that in the future. Thank you. So, and we'd like to take your questions, if any.
Thank you very much. Over to you.
Yeah, thank you. So in the last you mentioned like you didn't use any kind of API. So
yes,
but in the slide you mentioned about Django.
Yes, we've used Django.
For the web framework.
So here.
Yeah.
Django framework. Yes.
So can you just throw some light on the database schema?
So the data, we did not use any database. The values that you are passing here are actually passing directly through the model, and the prediction is being made.
Yeah, actually in the slide you have used database PostgreSQL.
Yes, we've used that for our team page only. We haven't used it for the model. So initially what our aim was to use an API, but due to time constraints, we could not implement PostgreSQL or any REST framework.
So can you show us the deployment?
Yes, sir. So
and how would be beneficial for the end user?
I mean, let's say if someone wants to predict the gold price, then he can actually fill these values and can actually predict the values right in front. Now, this is only for gold, but our data set also had for S&P and Dow, as I said, plus there were other elements such as silver and palladium. So we would also try to predict for them if possible.
Okay. Like you, in the starting of the page where there is no prediction, you have mentioned a lot of features which may not be like easily understandable by the end user. So
Yes,
how would you deal that problem?
So I believe we can add a description here for each value as to what is that and how this value is being used, as a small description here itself.
Okay, thank you.
Thank you so much, sir.
Yeah, solid job. I have just an observation. Can you please move to your slide? Yeah, so initially I thought it was a typographic error, and well, I think I saw it about 3 times in your slide. So if you move to the first one is move to your index where you have your index. Yes, so number 6, I can see hypertuning. Can you move to your process flow? Yeah, I can also see modeling and hypertuning. Then can you move to your conclusion? Yeah, I can see recent data sets with more hypertuning. So please, what is hypertuning?
So initially, when we were trying our modeling, we found that there were many features that were dependent. So we tried with that model. Then we readjusted it based on a feature selection and tuned a bit, and then we found that we reduced the features to 8 from about 6.
Yeah, that is for feature engineering. I mean, I am seeing hypertuning. What do you mean by hypertuning? I'm seeing it 3 times in your slide. Yeah, it's fine. It's fine. Just to correct you, it's actually called hyperparameter tuning. So it's a typographic error. Well, yeah, because I saw it 3 times in your slide. That's why I decided to bring it out. But it's fine. Thank you very much. Good presentation.
Thank you so much.
Yeah.
Thank you very much.
Should I stop sharing?
Yeah, you can stop sharing. Thank you very much, Ijanova.
Thank you so much.
On to our second to last group for the day, Group RNN, represented by Winston C. Aneke and Chris Olawori.
Hi, good afternoon, everyone.
All right.
Yeah, please, I would like to make, I would request for Winston to be a co-host. You'll be sure. Okay, all right. All right, so good afternoon once again. My name is Praise from the RNN project group. And our project is a time series model. Please go to the next slide, please. Yeah, please go to the next. Yeah, thank you. So our model is a time series model that we want to use to analyze the air quality index of Madrid, Spain, using the data set from the year 2001 to 2018. And with the analysis factors contributing to the quality of air in Madrid, we analyzed and we deployed a model for possible prediction. Next, please. Yeah, so understanding the problem and the problem statement is that authorities in Madrid, as the government, have been faced with challenge of combating. Next slide. I'm on the next slide, please. Understanding the problem. Okay, let me just continue because of our time. Understanding the problem. Okay, please understanding the problem. Authorities in Madrid have been faced with challenges of combating the deterioration of air qualities in the city. So I'm reading the problem statement now. And secondly, you get it now. So prediction of air pollution at different elevation and station proximity. So next slide, please. Yeah, so these are the following possible things we can analysis and what we can do with the data. We can see how different gases correlate. We can check for the trends and and so on. But we as a team, we focused on the second one here, which is, are there any trends in the changes? So we'll be focusing and be looking more on the trends. So please, next slide. Yeah, so our approach, we did our data cleaning, we did our analysis, and we built a linear regression model to forecast the air quality index in times to come, that is in years to come. So the data set we used were gotten from Kaggle, and it's a data set, it's a Madrid data set from the year 2001 to 2018. So next, please. Yeah, so our data cleaning, so we had a whole lot of missing values, and we decided to replace the missing values in other features, and yeah, we replaced the missing values with respect to stations with their median values, and we also dropped columns where the missing values were actually too much, so that we are left with just some of the gases, some of the variables, to have a very precise analysis. So on to the next slide now. That's the graph. Yeah, so this is a graph that's actually showing the percentage of missing values of all these variables, all these gases that we have here. And we could see that some of them are just too much. So that is why we had to perform our data cleaning, and we moved some of the data there that the missing values, some of the columns that the missing values were actually too much. So next, please. Yeah, so this is a plot that is showing the relationship between latitude and elevation. So we know that elevation is how high a ground is from the sea level, and places where they are high elevation, they tend to have air quality such as lower oxygen, strong wind, and some other things. So from this graph, we could see that there's a positive correlation between the latitude and the elevation. So anywhere there is a high latitude, we would most likely have high elevation, of which the air quality there will mostly be a air that has lower oxygen, strong winds, and so on. So next.
You have less than a minute.
All right, so okay, so just go to the graph, yeah. So this, we were showing the plot per year. We could see the trends of the gases, of the air quality index rather. So we could see that from the year 2001 to 2018, these are the trends of the air quality index. And okay, please let's quickly go to the simple linear regression so that okay. So stop here, please. Yeah, so yeah, we did we compared 2 years, that's 2012 and 2013, to see how they relate, how the increase, how the trends relate with each other. And then we could see from this graph, yeah, so in this graph we could see that 2012 the blue stand for 2012, while the orange stand for 2013. Next, please. Next slide. Next, please. Here we train a linear regression model with air quality index as the target variable. So we're trying to predict the air quality index in the future, that is in recent times to come. And here, this is the outcome we have. This is the value we got from our linear regression model that we plotted here. So we could see that the trends do not get any better. They keep on increasing, and this is not a good thing. So now our conclusion, the final slide. So our conclusion is that with research, we've seen that air quality index above 100 is unhealthy. So as a result, the government should, enact laws to mitigate activity. That is, the government should try and curb the releasing of this gas to the atmosphere. So this is our prediction and our conclusion of the project after checking through the trends and seeing how the gases have been increasing over the years, and also building a model that could forecast the future trends, which are not so good at all. And so we advise the government to actually enact laws to curb the releasing of these gases into the atmosphere. Thank you very much.
Thank you very much. Thank you very much. Our judges, please go on.
Yeah, so good work. Okay, so you mentioned that print the data. Yeah, I'm getting an echo.
Can you please mute yourself? When you want to answer, you unmute.
Yeah, so you mentioned that you trained the data with a linear regressor, but we cannot see any metric. So how good is your model? Where is the metric for us to judge your model? Or what metric did you use?
Actually, we didn't include the metrics. During the course of the project, we actually forgot to do this. So we only trained the model and use the predicted value to do some forecasting.
Yeah, so how good will you say your model is without a metric?
Yeah, so due to the time, we were not able to actually do more on this. So this will be one of the process to upgrade this project in subsequent times.
Yeah, so I don't know, but I think at least there should have been a metric. If it is the RMSC or the R squared, you should have shown us something.
Yeah, that was an error.
Yeah, what did you say? I didn't get that.
Yeah, so that was an error on our end, or it's from our end.
Well, that's fine. So yeah, that's all from me. Thank you.
Can I stop sharing the screen?
Hold on. Shimon, do you have any questions for you?
Oh.
All right, you may stop sharing your screen.
Okay, thank you very much.
I can stop sharing the screen.
Our very last group present today, Group SVM, represented by Ankit Kumar and Daniel Owolabi.
Hello, good day, everyone.
Good day, Daniel.
Okay, can I share my screen?
Yeah, you can.
All right. Okay, I don't know if you can see my screen.
Yeah, it's visible.
All right, thank you. Good day, everyone. This is the team SVM, and this is our presentation on the Premier project as given us by the HDSC Data Science Group. And it's going to be a project on checking the trend in the e-finance industry using the research data set provided for us from the years 1981 to 2019. These are the team leaders of my group, and my name is Daniel Owolabi. I'm presenting on behalf of the SVM group. The world has become electronic these days, and with it, the finance industry. So basically, financial services has graduated from presenting their services in person to moving it online, electronically, and using new technological trends. And why? It saves time, introduces paperwork, and chances of fraud. The key drivers of development in the e-finance industry include technology globalization, competition between finance industries trying to deliver their services at the best optimizable way to their consumers. So in this project, we are trying to uncover the trend in the e-finance data, like I mentioned initially, from the year range 1981 to 2019, and using the research data set. The source of our data set is cargo.com. This is the approach we took in solving this problem: profiling and cleaning the data, exploratory data analysis, text cleaning, feature engineering, basically text vectorization using bag of words, plots for the engineer text, the bag of words that we generated, model training and inference. About the data set, this is a description of the data set. We have author ID, title year, source title. These are basically just columns describing the publication for that year, for each of the years that we have. These are the top 5 values for our data frame. You can see the author and all the values, all the features, sorry. In the data, we had about 228 rows in our data and 46 columns. We checked the percentage of the missing values in each feature, and features with missing values having a threshold of 60%, like above 60%, null values were dropped. And we also, when we were carrying out exploratory data analysis, we found out that in the index keywords and the author keywords were basically describing the same thing, but for the author keywords, we had a lot more missing values. But the author keywords actually contained more keywords than index keywords. So what we did, I'm going to talk about on that later. So during the exploratory data analysis, we actually found out that most of the publications that we have are conference papers and articles. We plotted a bar graph of the publications per year, and we discovered that in the 1980s to the early 2000s, we barely had publications. For 2001 to 2009, we had a lot of publications. Most publication was in 2011, and it actually reduced, but it was generally more in the last decade of the given data set. Most of the publications were originally written in English. So we infer from this that most of the publications were preferred to be read in English. We also plotted a bar graph of the authors. We separated the authors to individual papers, and we discovered that only, the most papers written by a single author was 6 by Martin P.L. We also plotted an histogram of the number of words available for the abstract columns, and we discovered that we had an average of 70 to 180 words from the graph that we can see. Some publications actually had no abstracts given. Text cleaning and vectorization. To achieve this, we lowered all of the text so that they will be in the same format. We removed stop words, prepositions that gave no intuition into the trend in the e-finance industry. We tokenized the data. We lemmatized so that similar words like finance, financial will become a single word. We removed frequently occurring words that will not necessarily show the trend, but for some reason they are going to be more in the data set, like finance, data science, just one of the publishers for publications. Bag of words, count vectorizer class in Python was used to generate bag of words. We also used n-grams to check the integer n sequence of text so that we can get more sense instead of just checking the frequency of the most used words in the abstract column. The author keywords and the index keywords. So we basically just filled in the missing values in the author keywords that had a lot of null values with the index keywords, so that we had just a single feature of keywords that we can use to check the trend in the e-finance industry through this research data. And we found out that the notable most occurring words are electronic commerce, e-banking, web services, technology acceptance model, innovation, data privacy. This is the frequency of the most occurring words. Actually, we found out that there was some kind of disparity in the number of publications that we have per year. So we actually have fine-grained distribution, but for the purpose of this presentation, we just present for the ranges 1981 to 2000, 2001 to 2009, and 2010 to 2013. You can see that in the first one, we have health as the most occurring word. Second, we have information for 2001 to 2009, and services model. These are the graphs.
Please round up. Please round up. You've extended
Then we also drew a bar chart for the top n-grams to check the end sequence of information. Found out that we have health plan, European instrument, office automation in the year 1980 to 2000. We have the service intelligence, mining grid. In the last decade, we have web service, big data. We also plot top 3 grams so that we can get more information. We see that in 2001, 2009, we have flexible intelligence solutions surfacing. We have fingerprints, classification algorithms, maybe for protecting the e-finance industry and your account. In 2019, we have automated trading engine stock price prediction for the top 3 rounds. Our basic findings from this is that the e-finance is moving towards intelligent systems, automated systems, prediction algorithms, intelligent systems that can help bolster the delivery of e-finance industry services. Most importantly, here, we attempted to generate a word embedding to preserve the semantic information in our abstracts and cluster it. But because we did not have a lot of wide domain knowledge in this field, we plotted the graph and we explained the simplest score of our 0.75, and the results that we actually had when we checked similar words to the centroids of our clusters. We found out that security was common in both of them. So probably we have just one cluster we have. This is not very definite. So future work, we would like to use the time series data we have to predict the to forecast the trend in the e-financing industry for maybe the next 2-3 years. Thank you.
Thank you very much. Over to you, our judges.
Yeah, thank you, Daniel. Yeah,
Yes.
in the slide number 15, you have mentioned about tokenization and lemmatization.
Okay, yes.
Can you just give me a brief difference between what do you understand by tokenization and what do you understand by lemmatization?
Okay, on that, for the word, you can see I actually wrote word tokenization and sentence tokenization. And what we're trying to check for the frequency of the most occurring words, we use word tokenization since we need individual words used in the abstract colon. And for sentence tokenization, we tokenize the sentences so that we can get some kind of sequence in the text. So tokenization is basically just forming single values for each of the text or group of text as we want to process it to generate some kind of features for it for modeling. And then lemmatization, like I explained, is just, did you ask me to explain lemmatization?
Yeah.
Okay, yeah, lemmatization, like I mentioned, is to make words like finance, financial, financing, a single word. But instead of using, what is the other one? I can't remember right now. Lemmatization has meaning. Instead of not having meaning like the other, there's another one we can use. I remember the word, but I don't know why it's not coming to me right now. But lemmatization has meaning. That's why we use lemmatization.
Yeah. So you have also mentioned about bag of words. So how did you achieve the bag of words?
We use the count vectorizer.
What were the steps? What were the steps that you did?
After cleaning the abstract colon, we used the count vectorizer class to fit each of the abstract colons. But instead of fitting for all of the years, which is going to result in me having to present a lot of slides for each of the years, that's why we grouped the years into 1981 to 2000. So we had just like a single abstract for all those ranges of years. And since it is just text documents, grouping by these ranges, we're able to concatenate the strings to form a single string for the ranges of the years.
Okay. And you also mentioned like you tried to model it into word embeddings. So what were the challenges that you faced? And are you
the major
to solve them
challenge
in future?
Okay, the major challenge is how do I put it now? Knowledge. The most important. I feel like we don't have enough domain knowledge in this yet. We were expecting probably a project on linear regression. So maybe if we find more out, we'll be able to interpret the results we get from the word embeddings and probably forecast using time series, the time series we have. And the data set that we actually had was very, very restricted. Like I mentioned, we are just 228 rows. And it was the resolution of the time series was just years. We do not have months or days, or maybe that's not important, but like months might actually give us more sense into how to predict for the future.
Okay, then can you just summarize your findings? What have you achieved through this analysis?
With this analysis, we uncovered that in 1981 to 2000, we have health for the most occurring words, information and services in 2010 to 2019, but that did not really reveal anything. That's why we went further to check the end sequence information for the top grants. So we see office information, service intelligence, big data for each of these year ranges respectively. So we can say that the e-finance industry is moving towards using data to optimize their products for delivery to consumers in the best. We even have automated trading engine, stock price prediction in the last decade of years. So this gives us a general sense of the trend in the e-finance industry.
Okay, thank you.
Can I stop presenting?
Yeah, you can stop presenting.
Thank you.
Yeah. Thank you very much, Anit Kumar and Daniel Owolabi. Wow. We've come to the very end of our presentation series, which started yesterday, where 11 groups gave us a splendid presentation and the other 11 followed suit today. I want to extend a very big thank you to our judges in the persons of Shivam Singh Rathore and Damilola Shubowale for taking out time from their very busy schedules to grace this occasion. Thank you very much, our judges. And also my thank you goes to all the participants of today's presentation, all the people that presented and the groups and the spectators. You were all awesome and great. Thank you very much. I wish everyone a happy weekend and enjoy the rest of your day. Till we meet next time. Thank you.
Yeah, thank you very much.
Yeah, thank you very much.
Thank you very much, sir.
Yeah. Bye, everyone.
Yeah, have a nice day and enjoy your weekend.